Okay, so today I'm going to be talking about converting from U.S. customary to metric and metric to U.S. customary. And so I've copied some conversion rates from your reference paper on the front here. So if you prefer to have this out, this should be glued into your notes. We folded it in half with our gallon land notes. So this should be in your notebook already. And we're going to be looking at this side column here because if you remember, we talked about this column being the U.S. Customary column, this column being the metric column, and then this column being the one that bounces back and forth between the two. So I'm going to kind of keep this to the side. I also am going to make sure that I have my notes here that open up like this. They'll get glued in to my notebook with this blank side getting the glue. And I'm also going to have my calculator handy and close so that I can use it to help me as I'm converting. So this first problem is talking about 10 pounds equals blank kilograms. So the way that I always do these problems, I do these problems a little differently than most, but I think that when you get into double conversions later on in math, this way will kind of help you set things up and see why things work the way that they work. So 10 pounds, and I'm going to multiply that by what we call a conversion factor. And I'm going to put the number of pounds on bottom because I want these two things, if you remember from multiplying fractions, that labels can cross-reduce just like numbers. So the pounds, because they're across from each other, will kind of drop off. And I want kilograms to be left. So I'm going to put kilograms in my numerator so that that's on top with my answer when I get my answer. And so what I'm asking myself here is how many kilograms equal how many pounds? And this is just like multiplying by 1. Because these two things are equal, just like 3 equals 3, when I put 3 over 3, that equals 1. And anything times 1 is always itself. 10 times 1 is 10. So I'm going to multiply by a conversion factor. And so I'm going to pull this sheet out here to help myself. I'm looking for kilograms and pounds. So I see here's pounds, and I see here's kilograms and pounds. When I can, I always put 1 pound. I always put 1 in my denominator. I make this like what we would call a unit rate, where the denominator is 1. And that's just because then I can multiply straight across, and I don't have to worry about any division later on. So when I can, I put pounds. I put them across from each other. We can always do that with the new label that I want on top in my numerator. And then when I can, I put a 1 with the denominator. So 1 pound is equal to 0.454 kilograms. So I'm going to put 0.454 kilograms. And now, just like a fraction, this is like over 1. I'm going to come straight across 10 times 0.454. Use my calculator. 10 times 0.454. I get 4.54. My pounds cancel out. 1 times 1 is just 1, and anything over 1 is itself, so it's almost like I can ignore that. And I'm left with kilograms as my answer. So I get 4.54 kilograms as my answer. Now on all my answer keys, you're going to see two different answers. You're going to see the one where we multiply. You're going to see the other one that uses the opposite conversion paper. So I'm just going to show the work over here since I answered and labeled right here. I'm going to write 10 pounds again, and I'm going to multiply it by a conversion factor that has pounds and kilograms. But if you don't put a 1 in the bottom, this is what happens. If you tell me that 1 kilogram equals 2.2 pounds, again, I have the same, it's multiplying by 1 because 1 kilogram equals 2.2 pounds. That's like multiplying by 1 because these two things are equal. But now what happens is this is like 10 over 1. So 10 times 1 is equal to 10. And 1 times 2.2 is equal to 2.2. And now my fraction bar tells me to divide to get my final answer. So I have to do 10 divided by 2.2, which ends up being 4.454545. And in all of our things from now until the test, we're going to be rounding to the nearest 10,000th, with there's 4 places out. Oop, and I wrote this wrong. Let me rewrite this. This should be, 4.545454. 10 thousandths is 1, 2, 3, 4 places out. The 4 looks at the 5, and the 5 tells it to round up. So this would actually become 4.54 And I would accept 4.5455 as an answer, or I would accept 4.54. And the reason that those two answers are just a little bit slightly different is because they round the conversion factors. 2.2 and 0.454 are rounded to be in the best terms that they can be. So you'll notice that these two answers are really similar, but not quite. So there will almost always be two possible answers for these problems, and I'm going to kind of do them as one here, and always make sure that I label my answer when I'm done.